The video today is in part about the standard models through the ages, from Ptolemy's Earth-centered standard model to the sun-centered standard model of Copernicus, and to the current standard model, which assumes no center. And finally, to the disclosures in the Urantia Papers that describe a universal center at the Isle of Paradise.
The following two studies examine concepts of current astronomy and the architecture of the universe disclosed in the Urantia Papers. The standard model of cosmology rests on Einstein's general relativity, on subsequent theoretical work, and on observations and measurements made from within the range of our instruments. As a model, it is a hypothetical explanation for observed data, inductive, revisable, built by researchers reasoning from instrument readings toward an account of what the data imply. The Urantia Papers, on the other hand, disclose. They do not hypothesize. They describe a universe with a geographic center, space levels, an administered structure, and a force-energy economy. An account composed by beings who present themselves as knowing, offering calibrations for the researcher to work with. The studies that follow take the disclosed calibration data and develop a working model from it. Study 1, Einstein's equation. This is a question and answer study comparing Einstein's mass-energy equation with the energy equation disclosed in paper 42 of the Urantia book, and naming the 1917 assumption that study 2 will examine. Question 1. What did E equals mc squared achieve, and what did 1917 add to Einstein's cosmology? In 1905, a 26-year-old patent examiner in Bern named Albert Einstein published 4 papers in a single year. The last contained 4 lines of mathematics that established the equivalence of mass and energy, E equals mc squared. The energy content of any mass equals that mass multiplied by the square of the speed of light. It is a compact, precise, and universal statement, valid in every reference frame, for every observer. It remains one of the most verified results in physics. 12 years later, in 1917, Einstein applied his completed general relativity to the universe as a whole. The field equations had refused to yield a static solution. They predicted a cosmos that must be expanding or contracting. The prevailing view held that the universe was fixed and eternal, and Einstein shared that view. To make the equations produce a static result, he introduced 2 things in that same paper. First, a simplifying assumption he called the cosmological principle, that the universe at large scales looks the same everywhere and in every direction, with no center and no preferred direction. Second, a mathematical term, the Greek letter lambda, the cosmological constant, added to the equations to counteract their dynamic tendency. When Hubble's 1929 observations confirmed that the universe is in fact expanding, vindicating what the equations had always predicted, Einstein withdrew lambda and called it his greatest blunder. The cosmological principle remained. It became the foundation of every subsequent standard cosmological model. The current standard model is called lambda CDM for its inclusion of a cosmological constant and cold dark matter. E equals mc squared survives to this day. It describes a precise relationship in the matter we can observe. The question it does not address is where the energy came from. That question is what the Urantia Papers take up. Question 2. What does paper 42 say about energy, and how does its equation compare with Einstein's? Paper 42 of the Urantia book is titled Energy, Mind and Matter. Its opening statement establishes the paper's seminal character. The foundation of the universe is material in the sense that energy is the basis of all existence and pure energy is controlled by the Universal Father. The paper addresses both manifestations of energy: mind as the non-mechanistic register in which creation is planned and administered, matter as the mechanistic register in which energy becomes observable. This study focuses on the energy to matter side, which is where Einstein's equation operates. Within paper 42, at section 4, paragraph 11, the energy equation is given. The first sentence: the increase of mass in matter is equal to the increase of energy divided by the square of the velocity of light. The second sentence: in a dynamic sense, the work which resting matter can perform is equal to the energy expanded in bringing its parts together from paradise, minus the resistance of the forces overcome in transit and the attraction exerted by the parts of matter on one another. Some may read this passage as a confirmation of Einstein's equation. That reading is partly accurate and partly incomplete. The first sentence does touch the same territory as Einstein in different form. The second sentence moves into territory that Einstein's equation does not address at all. The two sentences together do something Einstein's equation does not attempt. Question 3. How do the two sentences differ from Einstein's equation, and what do they add? Einstein's equation is a static identity. Mass and energy are the same thing in different units, everywhere, always. Written symbolically, E equals mc squared. The first sentence of paper 42, section 4, paragraph 11, describes something different. Expressed symbolically, delta m equals delta E divided by c squared. The increase of mass equals the increase of energy divided by the square of the velocity of light. This is a dynamic relationship, a description of what happens when energy is added to a material system, not a universal equivalence. The papers affirm a deeper equivalence elsewhere in paper 11, where they say all physical force, energy, and matter are one. That unity runs the full chain from mother force of space to organized atomic matter. The first sentence of 42.411 is situated at the bottom end of that chain, the place where Einstein's equation operates. The second sentence does something Einstein's equation never attempted. It names an origin and accounts for a journey. Expressed symbolically, W matter equals E paradise minus R transit minus A binding. W matter is the work resting matter can perform. E paradise is the energy expended in bringing the parts of matter together from paradise. R transit is the resistance of the forces overcome in transit. A binding is the mutual attraction exerted by the parts of matter on one another. Einstein's equation has no origin term. Energy and mass are interconvertible anywhere, with no reference to where the energy came from. The second sentence gives the equation a source, paradise, and an accounting of what was invested along the way. The investment was administered. Paper 42 identifies the orders of intelligent beings who carry out the transmutations at each stage: force organizers, power directors, power centers, and physical controllers who manage the final transmutation of the automaton into the circuits and revolutions of the electron. Modern physics recognizes nuclear binding energy as a correction to Einstein's base equation, but treats it as secondary. The papers build the full accounting into the foundational description. Question 4. What does the paper 42 equation disclose that Einstein's equation cannot reach? The two sentences together disclose that the universe has an economy. Force energy originates at a named source, descends through a sequence of transmutations managed by intelligent beings at each stage, and arrives at organized matter bearing the costs of the journey. That organized matter is the substance of material creation, the planets, the suns, the physical abodes of mortal life across the grand universe. The energy stored in any physical system represents what was invested from the Paradise Circuit minus what was drawn off in transit and consumed in assembly. Einstein's equation describes the bottom of that chain accurately. It is locally valid, precisely verified, and silent about everything above it. No source, no journey, no agent. That silence is not a failure of Einstein's mathematics. It is the boundary of what the cosmological principle, as the framework within which modern cosmology operates, allows the equation to ask. The cosmological principle was introduced in 1917 under pressure from intractable mathematics not derived from observation. It remains an axiom, assumed but not confirmed. The revealed architecture of the Urantia Papers offers something of a different kind. A named center, a specified structure, a force-energy economy with disclosed calibrations. The observable consequences of that disclosed architecture are what the second study in this report examines. I have again perpetrated something about gravitational theory which somewhat exposes me to the danger of being confined in a madhouse. Albert Einstein, in a letter to Paul Ehrenfest, early 1917, written on the occasion of his paper introducing the cosmological constant. Study 2, Astronomy's Anomalies. The first study in this series, Einstein's equation, examined what the Urantia Papers disclose about the force-energy architecture of the cosmos, an absolute center, a named source for all energy and matter, a descent through administered transmutation stages, a breathing medium, a clock rate gradient anchored at eternity, and a force-energy economy managed by intelligent beings. The cosmological principle contained no provision for any of it. This second study places instrument data, the actual measurements made by telescopes and detectors, against that disclosed architecture. Each anomaly the Standard Model now carries is examined alongside the architectural feature the papers disclose that accounts for it. The anomalies are not isolated surprises. They share a common upstream cause. Question 1. How has the center of the cosmos been understood throughout history? For more than 1,000 years, the Ptolemaic system was the standard model of astronomy. It placed Earth at the center of the cosmos and described planetary motions as combinations of circles moving on other circles. Its mathematics was careful, its instruments precise, its astronomers genuinely skilled. The system predicted planetary positions well enough to keep calendars, guide navigation, and time religious observances across the Mediterranean and medieval Europe. As observations accumulated, Ptolemaic predictions began to drift from what the sky actually showed. The response was to add epicycles, additional circles superimposed on the main motions that brought calculations back into agreement with the data. When those corrections themselves failed, further refinements followed. By the 16th century, the system required dozens of epicycles to keep pace with the best available observations, each mathematically competent, each designed to save the appearances. When Copernicus proposed in 1543 that the Sun, rather than the Earth, was the center of planetary motion, the epicycles dissolved. What had required dozens of nested circles required instead a handful of ellipses. The patches disappeared because the upstream assumption had been corrected. This pattern is diagnostic. The mathematics of the Ptolemaic system was often superb. The center was what failed. The Copernican correction moved the center from Earth to the Sun. The cosmological principle, adopted in 1917, removed the center entirely. Each step was a centering decision. The current Standard Model's centering decision is the one this study examines. Question 2. What is the cosmological principle, And how does it produce the numbers astronomers use? The cosmological principle is the assumption that the universe, viewed at sufficiently large scale, is homogeneous, the same everywhere, and isotropic, the same in every direction. No location is special, no direction is preferred. There is no center. Einstein adopted this assumption in 1917 as a mathematical simplification. His field equations of general relativity are extremely difficult to solve for an entire universe. The cosmological principle made them solvable, allowing Einstein, Friedman, Lemaitre, Robertson, and Walker to reduce the full complexity of the field equations to a single metric, the FLRW metric, describing a uniformly expanding or contracting space. The assumption was not a measurement. It was adopted because without it, the mathematics did not yield a tractable solution. Einstein himself introduced the cosmological constant lambda in the same 1917 paper, attempting to force a static universe from equations that naturally predicted a dynamic one, a decision he later called his greatest blunder. From it, a derivation chain follows. The FLRW metric yields the Friedman equations. The Friedman equations produce the Hubble parameter, h0. From h0, every other derived quantity follows. Co-moving distances, look-back times, the 13.8 billion year age of the universe, and the density parameters that divide the total energy budget, hypothetically, into approximately 5% ordinary matter, 27% dark matter, and 68% dark energy. Every number in this chain depends on the one above it. Remove the axiom at the top, and the downstream numbers become indeterminate. Run backward, the same equation implies a singular moment of origin, the event the Standard Model names the Big Bang. Question 3. The Hubble tension. What does the disagreement in expansion rates disclose? The Hubble parameter, h0, describes the current rate at which the universe is expanding. Two independent methods of measuring it return different values, and the disagreement has persisted through decades of careful refinement. Measurements from the early universe, derived from fits to the cosmic microwave background using Friedman's equations, yield approximately 67 to 68 kilometers per second per megaparsec. Measurements from nearby galaxies using calibrated distance ladders built on the Cepheid variable stars and Type 1a supernova yield approximately 73 to 74 kilometers per second per megaparsec. The discrepancy is roughly 8 to 9%, well beyond the margin of measurement error. h0 sits in the middle of the derivation chain. When two independent paths to the same number disagree at this level, either one or both measurement chains carry a systematic error, or the framework that produced the chain requires revision. The architecture the papers disclose identifies the structural sources of error in redshift-based distance estimates directly, when it says, "This apparent speed of recession is not real. It results from numerous factors of error embracing angles of observation and other time-space distortions." The greatest single factor is architectural. The vast universes of outer space and the realms next to the domains of the 7 superuniverses seem to be revolving in a direction opposite to that of the grand universe. Counter-rotating space levels produce relative velocities between observer and observed that register as recession. Space respiration, the 2 billion year cycles of expansion and contraction that alter the tension of the medium through which light travels, compounds the distortion. These are not random errors. They are the expected signatures of a structured directional cosmos that the cosmological principle assumes does not exist. Question 4. The missing mass problem. What does the architecture of the papers offer in its place? Galaxy rotation curves measure how fast stars and gas orbit the center of a galaxy, as a function of distance from that center. Vera Rubin and Kent Forbes observations in the 1970s and 1980s established that stars in the outer regions of spiral galaxies orbit at velocities that remain flat, roughly constant, far beyond where the visible mass of the galaxy would predict a decline. Gravitational lensing shows the same discrepancy. The bending of light passing near galaxy clusters exceeds what their visible mass can account for. Both are instrumentally confirmed measurements, independent of the cosmological principle. The Standard Model resolves the discrepancy by postulating dark matter, an invisible substance that exerts gravitational attraction but does not interact with light. The amount required is substantial, roughly 5 times the mass of all visible matter in the universe. Dark matter has been sought in underground detectors and particle accelerators for decades without confirmed detection. The papers describe 2 kinds of material gravity operating at different scales. The center and focal point of absolute material gravity is the Isle of Paradise. Local or linear gravity, by contrast, pertains to the electrical stage of energy or matter and operates wherever suitable materialization has taken place. Material that responds to absolute paradise gravity but has not yet reached the electronic stage of organization would exert gravitational influence without emitting or interacting with light, the observational signature attributed to dark matter. The papers also identify where the preponderance of mass in the cosmos resides. This central isle is the most gigantic organized body of cosmic reality in all the master universe. Surrounding Havona, the central universe of 1 billion perfect spheres, are the dark gravity bodies, named in the papers for their gravitational character. Owing to the enormous encircling masses of the dark gravity bodies about the fringe of the central universe, the mass content of this central creation is far in excess the total known mass of all 7 sectors of the grand universe. The center of the architecture holds mass at a scale the Standard Model has no category for, precisely because the Standard Model has no center. Question 5. The accelerating expansion problem. What structural feature replaces dark energy? Observations of Type 1a supernova in the late 1990s established that the expansion of the universe is accelerating, increasing in speed rather than slowing under gravity, as standard models had predicted. Within the FLRW framework, this acceleration requires a repulsive energy component. The Standard Model names it dark energy, assigns it approximately 68% of the total energy budget, and has not detected it. Together with dark matter, the 2 undetected components account for approximately 95% of the universe's total energy content in the Standard Model, leaving roughly 5% for the matter that instruments have actually measured. What the papers disclose in its place is structural. The semi-quiet zones between space levels are permanent features of enormous scale. Such an arrangement exerts anti-gravity influence and acts as a brake upon otherwise dangerous velocities. The Standard Model requires a repulsive energy because it has no architectural category for large-scale anti-gravity. The disclosed architecture names exactly this category as a feature of the spatial structure, not a postulated energy with no laboratory analog, but a disclosed property of the boundaries between organized base levels. Question 6. The cosmic microwave background anomalies. What does the preferred direction disclose? The cosmic microwave background is a nearly uniform microwave radiation detected across the sky, interpreted in the Standard Model as the thermal afterglow of the early universe. Its temperature map is the most precise instrument test of the cosmological principles isotropy requirement. At the precision achieved by the WMAP and Planck missions, the map shows features the cosmological principle does not predict. the quadrupole and the octupole moments of the temperature distribution, large-scale patterns that should point in random directions across an isotropic sky, show a statistically significant alignment with each other and with the elliptical plane. This alignment, sometimes called the axis of evil in literature, points in a preferred direction. An isotropic universe produces no preferred direction. Additionally, direct isotropy tests using large catalogs of distant radio sources and quasars have returned statistically significant departures from the cosmological principle's prediction at levels several standard deviations beyond expectation. The anomalies are features of the data. Question 7. The early galaxy problem. How does the revealed cosmology reframe it? Beginning in 1922, the James Webb Space Telescope detected galaxies at high redshifts, displaying characteristics previously associated with much later cosmic epochs: mature stellar populations, organized disk structures, established metallicity, and masses requiring substantial prior star formation history. A landmark paper by Lebet and colleagues, published in Nature in 2023, reported candidate massive galaxies at redshifts near Z=9, with stellar masses comparable to the Milky Way, observed when the universe was, according to the standard timeline, less than 700 million years old. The standard model assigns the universe an age of 13.8 billion years. The age the Big Bang timeline derives from the cosmological principle chain. Within that timeline, 300 million years is insufficient for stars to form, cycle through nuclear fuel, explode as supernova, seed the interstellar medium with heavy elements, and allow subsequent stellar generations to incorporate those elements. The observations are spectroscopically confirmed. The impossibility is a feature of the model's timeline, not of the cosmos. The disclosed timescale is of a different order. The trillions upon trillions of years that an ordinary sun will continue to give out heat and light well illustrates the vast store of energy which each unit of matter contains. Our own sun, described as having long since attained relative equilibrium at 6 billion years of age, will shine on as of present efficiency for more than 25 billion years. It is not stated whether efficiency will improve when the pulsations have minimized and the superuniverse organization matures. Regardless, this ordinary mid-sized star's disclosed efficient period already exceeds the standard model's age for the entire universe. In a cosmology with timescales of this order, mature galaxies at great distances are expected. The assumption produced the impossibility. The instrument data did not. Question 8. What correction does the cosmological principle still await? The Ptolemaic parallel this study opened with is now complete. The mathematics of the standard model is careful, its instruments precise, its observations instrumentally confirmed. The upstream assumption is the unverified one. When the axiom of no center is replaced by the disclosed center at paradise, placed at the top of the derivation chain, the anomalies the standard model now carries no longer require invisible components and unverified parameters to save the appearances. The Hubble tension, the missing mass, the accelerating expansion, the directional anomalies in the cosmic microwave background, the impossibly early galaxies, each finds a structural account in the disclosed architecture. The pattern that required epicycles dissolves when the center is corrected. Ptolemy placed Earth at the center. Copernicus moved the center to the sun. Einstein's cosmological principle removed the center entirely, a mathematical necessity that became the foundation of every standard model that followed. The Urantia Papers disclose a cosmos with a center, paradise, stationary, absolute, the geographic origin of all force energy in the material creation. Closing. The two studies in this report establish the diagnostic and the framework. The anomalies accumulating in the standard model trace to a single upstream assumption, the absence of a center. The architecture the Urantia papers disclose accounts for each anomaly without adding invisible components, adjusting parameters, or abandoning the observations. The instrument data stands. What changes is the center. What remains is the constructive case, placing the disclosed architecture against what the instruments can actually measure and allowing the calibrations to close on numbers. Future studies include the location of Paradise Isle, Andromeda's anomalies, a revealed cosmic ladder, the universe energy economy, anti-gravitational lensing, and the Fermi bubbles. The Urantia papers describe a cosmos with a center, a direction, an architecture, and an economy. These studies are the beginning of working with what has been disclosed.
Let me open up the floor for questions, comments. Mr. Taylor.
Both of your presentations talk about recentering, and the quote that you didn't include may put both of these in perspective. That's that the ultimaton has Paradise as its nucleus. So talking to the energy model, the mass energy equation, and the cosmology might be a common denominator. We might talk about that. I would like to go back to that E equals mc squared concept and speak to the fermion-boson mix. If we think of photons or bosons as pure energy, i.e. no mass or massless, and fermions as having mass, and essentially fermions are energy spinning around in 720 degrees before they carry on, and photons and bosons are just ripples in the field. That would make energy, or the E part, kind of a boson, and the M part being a fermion. So you might rewrite the equation, photons equals fermions times C squared. And also, C in itself is more of a limitation of measurement. If time is just a measurement of motion, then C becomes the limitation of the measurement of the motion of light, or the speed of light. So it all starts to come down to even more elemental concepts with the Urantia book. So well done, brilliantly put together. Thank you.
Well, yeah, thank you for your comments. Yeah, you said a lot of things, and I'm not. I think I'll just leave it at that, because there's going to be various opinions about the way the universe is put together and how people interpret what the Urantia book says. And the interesting thing was, I know a lot of people have said that E equals mc squared is verified in the book, but it goes a little beyond that, quite a bit beyond that. And the way they say that, well, they speak of velocity where Einstein spoke of speed of light. The speed, I think that the speed of light, as is understood in a vacuum and in a universe that is isotropic, and it has the cosmological principle as its source, as its foundation, and it's an axiom. It's not really tested. It's just something that works mathematically. So the speed of light and the velocity of light is a variable. I think when it goes through a gravitational area, the time actually slows down, and if it goes through an anti-gravity area, that would be real fast clocks. They would move very fast. When light has to go from the outer space levels through semi-quiet zones, which are vast, and these semi-quiet zones have anti-gravity properties. So there are huge areas of anti-gravity between where we are and where these observed galaxies are. And so time would speed up and light would appear like if light had a wristwatch on it, it would go faster when it's going through these semi-quiet zones. So light from, say, a nearby galaxy, if there's a semi-quiet zone between us and them, it would indicate that the distance, it would show, the instruments would show the distance to be farther away than it actually is. And I think you might know what I'm getting at.
Thanks, Jeff. Tom?
So the cosmological principle and the HO are probably wrong, but they're doing great things for astronomy to get us to that point, to that level where we overcome the obstructions that occur in leading us to a real dynamic. The evolutionary universe comprehension, it bends towards truth, and it will eventually get there. And we're just so lucky to be in an age that has an epical revelation in our lives. So we got a head start on what's coming up. So I do have one quick question about, the universe is 14 billion years old, right? Yeah, according to the Big Bang.
No.
According to the Big
Yeah.
Bang.
Yeah.
So if that was correct, then black dwarfs would not have had time to evolve because they take longer to evolve when they're burning out. And as a result, I think maybe dark matter doesn't exist because the universe as we know it is trillions of years old. There's lots of dark dwarfs out there, black dwarfs, that have probably evolved into black holes and have been assumed and deteriorated and what have you. But there's so much more out there that we don't know about that it could be the matter that's driving. Now, I hope dark matter's found. I think that'd be really neat. This is purely intuitive, but that's what I wonder about. Thanks, David.
Well, yeah, as science advances, there's just more and more data than any human can actually look at. And when there's data, it needs to be explained. And the standard model today is an explanation of the data that they found through time. But as data keeps coming in through these advanced telescopes that the Urantia book talked about, things are going to change when you get this better information. And yet still, the standard model, you hear people say this is the most successful model ever. And I guess they look at each of these anomalies as just blips and mysteries that need to be looked at later. But everything else makes sense to them. And the mathematics works if you use um, the cosmological principle, which is not proved. It's just an axiom. It's just an assumption that they all make, and the math works. And the math works. Actually, E equals MC squared does work from our local standpoint. Out here, at our distance from paradise, which is the farthest distance that pretty much we will have because we're in the outermost regions of the super universe level. But eventually, we're going to be at the innermost regions of that super universe level, and things will be the same. I mean, the distance to this grocery store is going to feel the same, and it's going to take that much time to get there. But everything's going to be, from an overview, seemingly compressed. It's hard to understand. But I just wanted to say about the data that keeps coming in. I wouldn't have been able to do this report 3 or 4 years ago before we had AI to take the data that's in the Urantia book, compare it to other data in the Urantia book, and then on my request, look at the data that's coming in from science and the models that have been proposed, and to ask questions and dialogue with it. Every question and answer I think I have 12 questions, probably had 50 interactions to get the AI to understand what I'm getting at and what I think that the Urantia book is saying, and then to hear what it has to say about things that I don't know anything about, like, or just minimal about what current science is saying. And current science is just that, it's what's the science is of today. But if you look back 100 years ago, they had a current science then, and things have modified and changed. It keeps a lot of people employed too.
Right. I heard the other day a old clip from the comedian Norm Macdonald, and he was telling somebody, "I don't believe in any science." And they go, "Oh, really? You seem like a rational guy." He says, "Well, all of them except the current ones have been proven wrong. So what makes us think that these ones are right?"
Yeah,
So
many a truth is said in jest, right?
right. Corinne.
In part 2 of the presentation, question 6, and there was a slide, and on that slide, there's a little spot called the cold spot. I'm wondering if you could describe or explain to me a little bit what that is, because you didn't really mention it, and I saw it, and so I was just curious.
They measured the sky. It was an accident the way they found the cosmic microwave background, and it appeared to be coming from all parts of the sky. And so when they found this measurement, they had to explain it, and they explained it as the remnants of the Big Bang. And I guess it makes sense to them, but when it seemed like it was coming from all, but so everything would to be in line with the cosmological principle, it should all appear the same. But when they did really close studies of it, some of it was colder than others by like very small fractions of a degree or whatever. Um, so that's a discrepancy in the cosmological principle of everything being the same all around. Uh, so they named these things, and it's just an anomaly in the way they understand science. So they basically say it's a mystery or try to explain it in certain ways. But I think that we can understand it better when you think of all of the light that's being put out by all of the suns, trillions upon trillions and trillions. They never stop putting out this light for trillions of years, and it has to go somewhere, and it can't go beyond the pervaded space level, which has a limit, an up and down limit. If you look in probably paper 11 or 12. So it's contained, and it has to travel somewhere. So it's either going outward toward the outer space levels or inward toward paradise. And so I think it might be like a charge of this boundary zone between pervaded space and mid space, and uh, it might be able to be understood that way if you look at it through the revelation. But this is like that. I put it in future studies, so that's something we have to look at as researchers, not just me. I think other people should. It's offered to other people to look into too.
Thank you, David.
Thanks, Corinne. Thomas.
Does any of what the video said help us prove what is in paper 42 of the Urantia book?
Well, when I did one of my scientific symposiums, I had the pleasure of working with Marjorie Ray, who is a real scientist. And whenever I would say the word prove, she would say, proof might be good for mathematics, but it's not the best thing for science. And if you're going to say something proves something, I think you might be corrected later. So I would say that you're not going to necessarily convince people that are scientists about the accuracy of the architecture that is disclosed in the Urantia book. And related to that is the evidence that there's a creator. I think a lot of scientists, maybe most scientists, believe in God, but they don't bring it into their work because well, it's not, it's something that they can't get a handle on, that there's a first source and center. Maybe they could get into that, but I think it's hard to bring it to scientists unless you present it in a very rational way and they're open to understanding it.
And lastly, will CERN help these material scientists see the truth of what is in the Urantia book, or will it lead to something more nefarious?
That's dealing with things that are very small as opposed to what's very big and what we saw in the video. And that's another one of those topics for future study. I don't want to make any comments about what's happening there because I really don't know much about it.
Okay. Thank you.
Thanks, Tom. Jeff, let me call on Jan, and then I'll come back to you.
I'm asking about the factor of divinity. In 2023, you mentioned there were discovered 6 galaxies which are 300 million years old, which are too young for be so big. My feeling or thinking is that probably that's the super universes. We are being the 7th one. And reading the Urantia book, they say that divinity, 95% of whatever is covered by divinity in the universe is within those 7 super universes and Havana and Isle of Paradise. And outside creations, which we probably see on the sky, they don't have divinity force. They have just a matter, 95% of it. That means, do you find somewhere in the text the connection between divinity and the matter itself?
Yes. All matter and energy is sourced at the center, at paradise, and controlled by the Universal Father. So, yeah, there's a direct connection with divinity, and who's the upholder of the entire universe. They say if he left the place where he is now to go on vacation or something, the universal pandemonium would take place. So, in our understanding, it's essential to have a personal being in charge of this and have other personal beings or intelligent beings doing the work of changing the mother force of space, which has a presence at north end and south end of paradise and registers differently because of the work that it does to create the worlds that we live on. And that's, I think, the purpose of it. It's so that we can have, everybody needs a place to have, everybody needs a material abode. And that's the why of the universe, as far as I could see from the book, and that's disclosed. It's not something that can be proven, but it's something that can be understood as being rational and reasonable. And it is to me, and I think it is to probably everybody in this room, that there is a personal source for everything, for life, the universe, and everything. And that's all found in paper 42, ironically.
But my focus was more on if the factor mind over matter could be transfer into the Einstein equation, which will be changed delta E equals delta M times C squared. Can we add the mind over matter into this equation? That's basically more of my question.
Well, I mean, I would just ask you, do you have like an idea about that?
I mean, I see there is for reason only 7 super universes are basically feel or coordinate with 95% of divinity. That means there is a factor of intelligence within Paradise Isle, Havana, plus 7 super universes. And
Yeah.
then we have a outside creations which basically has only 5% of divinity. That means there is something happening in the universe which our scientists, not believing in God, does not consider at all.
Well, yeah, we're not gonna convince everybody that the Urantia book is, but all those outer space levels, which don't have anybody living in them right now, there might be beings who are, well, there have to be beings who are organizing it and putting it together. But
Yeah, that's the
they're
5% I'm talking about. Yes.
but if you ask me, a couple trillion years from now, maybe we'll know that the first outer space level is being populated, and we'll be a part of that as part of the supreme being extension into the purpose of what that supreme being is up to. I hope that helps.
Okay, thanks.
Yeah.
Yeah, thanks. I think maybe as a corollary, so we have the super universes, which presumably we don't know exactly what's in and what's out, and we can, that's a whole nother debate, but presumably we can kind of see most of that because we can clearly see outside of it too. We must be looking also at things in the outer space level. And is there anything, do we know, or does anybody know in the observation data that sees what might be the super universe collection of matter differently? Is there some distinction in the observable data between what looks like maybe the nearby group versus all these outer space levels, which the Urantia book tells us are quite a bit farther away and past some zone where time and light might not even be working the same to get to us, I guess. You'd think we would kind of, I know there's something like the local group and whatnot, but you'd think we'd kind of see some behavior close by that would be at least different farther away. But maybe that goes back to the idea that, this assumption that everything is the same and, how there has to be adjustment because, at some point, because we know that's not, or at least the book says that's not the case.
Right. Well, I think that the things of the outer space levels and the things of the super universe levels are the same, and all matter and energy and force are the same. How do we know that? Well, it says it. So that's part of the disclosure that
Right.
feeds our, philosophy.
Right. Well, I think, yeah, what Jan is saying is that God has poured some more energy in the form of in non-material forms, maybe into the super universes, right? There's a lot of stuff going on there, and maybe that accounts for these sort of young, and the Urantia book talks about adding energy, so maybe and somehow there's been kind of an acceleration of development in the super universes in ways that would have a physical manifestation as well that just hasn't taken place yet farther away, which might account for some of these time discrepancies. Maybe, who knows?
Right. It's like a dress rehearsal for what's coming after this.
Yeah. Thanks,
But
John.
also, if you can see the planet having created life is changing atmosphere, is changing the spectrum visible. I mean, we see something which is covered by divinity and is different than just an empty planet with no life on it.
It's designed. It's designed to be this way. The Earth is uh, if there wasn't certain designs there's so many things that have to come together for life to exist on any planet, that have water and atmosphere, and of course life can exist without atmosphere, and people can continue life after the end of their life here, or on a electronic people planet. Um, so I have some ideas about that I think I'll have to look at or explain better later, about time and why. No, I won't even start. I won't even start. Don't worry about it.
Okay.
Well, yeah.
Jeff.
Yeah, sorry for double dipping here, but this
No,
is
that's
such a
fine.
fascinating topic. Thank you, David, for bringing it. I want to ask if you're aware of what they call the fundamental density theory, which they call the omnium or all one density theory. It suggests that if you substitute c squared for the rate of change of distance with time squared, then everything boils down to density. So you got the equation strong, it becomes, strong force equals gravity at densities closer to one, and that gravity is a sort of a low density environment where it's very much less than one, and the electromagnetic force is equal to weak force. In other words, same energy, where electromagnetic is the long range and the weak force is the short range, or density variations on that. So that's a very interesting concept when we apply to paradise. So if you think of paradise as stationary matter, or ideally patterned matter, it's incredibly dense because there's no motion. And we all know, even a black hole is incredibly dense. But it still has some motion. It still has intellectual motion, sort of the Hawking radiation concept. So that's an interesting perspective.
Well, it's interesting that paradise is the most, what did they say? Organized body of matter, the most gigantic organized body of matter, or material, or creation. I don't have the quote right, but it's big and it's very dense, and like you were talking about density, so much so I think that there's no time there. Your watch is not going to work on paradise, because it's eternal. It reaches that level of eternity. And then when you go out to the beyond that, where the densest part of the universes are, time is slower. When there's gravity, even that's been proven with GPS signals and how they have to account for, I think the gravity of the Earth will affect the time that and it really requires time to find your position wherever you are. So all these things are testing out scientifically, but they don't have any way of saying that there's this huge anti-gravity zone. There's less matter or more matter, but it even goes to the point where there's like a high matter, and then it goes submatter, subgravity, I mean. They can't know that. They can't know that there's a paradise. There's no test for paradise.
Well,
it has to be disclosed.
Yeah, there may be a test for paradise if we can detect the directionality of gravity. Because if gravity has a direction, it might point to paradise. And really, the correction is more of a distance time relationship. Even for the GPS satellites, it's still a distance time difference function, because we measure the distances differently at different gravities. So it's interesting. And the other thing, totally unrelated to that concept, was I would ask if you consider Morontial energy as part of the dark matter, because when they detect dark matter, they tend to detect dark matter around real matter. And I would think if you're going to have mansion worlds, they should be close to real worlds, within reason, within astronomical distances. So I'm thinking maybe dark matter might be Morontia matter.
I don't know that they've detected it at all. They hypothesize that the way things look must have dark matter, and the way things are expanding so fast, there must be dark energy because how else could that be? But they don't know. They can't know the structure. They can't, paradise, yet maybe we can detect a high gravitational area that lies beyond the zone of avoidance, which is um, the the place beyond which you can't see with visible light. You have to use the light that can penetrate the dust and matter that surrounds this planet, and that is where the plane of creation is. So paradise will be not visible by any, you can't see it. Even if you could see in that area, the dark gravity bodies hide what's happening in the central universe. Um, but it is giving off signals, and they're assuming that signals are like if they have a high gravitational indicator that's beyond the zone of avoidance, they have to assume the cosmological principle says that there must be a huge galaxy system that is drawing um, they call it, what do they call it?
The great
Uh,
attractor.
there you go.
Yeah,
That's
great
it. You win.
attractor. Yeah, okay.
Yeah, but they think that it's huge amount of galaxies that are clustered in a certain area that is attracting, but that's an interpretation. They can't see that. They can say, well, this is what it must be because of the everything must be the same in all directions. But we know that things are actually getting closer and closer and closer together from our point of view and our position. So it's all interpretation about what lies beyond that. And it's very interesting that it's a very interesting topic of study, I think.
Thanks. Margaret?
Um, Great talk, David, but you know how much I appreciate your amazing work and your incredible brain.
Likewise.
Yeah, anyway, and thank you for mentioning the definitions about proof. I, as a scientist, am wed to the scientific method, and in the scientific method, except for the area of mathematics, particularly geometry, is the word proof. Actually, you may have it in a court of law and in geometry, but you don't really use it in science. You have supporting evidence and confirming evidence of a hypothesis. You never prove it. Because if you prove something, then inquiry stops. Okay. We do not want science to stop. All right. We want inquiry to move forward. So what we do is that we propose a hypothesis, and we either get substantial evidence to support it, or we disprove the hypothesis and develop a new one. And the humorist that said that, why should we believe science now because everything in the past has been disproved? Well, I'm here to tell you that probably 99.9% of what we know today is going to be disproved at some point in time. All right. And it's going to be vastly modified. And if we came back when we were finally enlightened life, and were able to enjoy what human science has actually developed, then we would understand all of our sort of hiccups along the way.
I'm really glad you explained that again.
Yeah.
It's very, very important.
I happen to know a lot of scientists that believe in God, but you cannot really bring that into your science, because science only developed is in the material realm and not in the spiritual realm. That doesn't mean that they are not spiritually active and spiritually. Fact is, there's some very famous ones that have won Templeton prizes that were Nobel Prize winners and also won the Templeton. And if you're not familiar, that's the big one for religion and science. They give as much money for that one as the Nobel Committee does. And there's some very, very famous ones. One that I knew was John Polkinghorne in England, who was a particle physicist who actually worked at CERN. And he also became, after he retired from being a particle physicist and writing some amazing books, became an Anglican priest and was an incredible, amazing man. We lost John just a few years ago. And then one of the in the United States, Charles Towns, who won a Nobel Prize in physics, taught Sunday school every Sunday of his adult life and had a tremendous belief in God. And was in some amazing study groups where he lived. So, these are examples of people that are doing the work, that have done the work that David has been describing in his presentation. And they're young scientists now, which I find just give me so much hope, is that this idea of the Big Bang and things only being X amount of years old and all this that has when I was growing up, we were taught two different things. We were taught the steady state and we were taught the Big Bang. And then miraculously, when I was about 13 or 14 years old, the Big Bang kind of like went, and nobody ever talked about the steady state, okay, which is sort of more or less like the time that we live in right now, because we've only existed during a time of expansion. We have not yet lived through an era of contrast as far as respiration is concerned. So this is another thing to understand, that how it has informed our scientists. But the question I wanted to ask David, since he's been reading in the area so much recently, and I must say I have been reading in other areas. Science is vast, and you kind of have to pick your domain. As Jeff has picked microtubules, which I applaud him greatly for that. But who do you think currently of the young astronomers or cosmologists that you've been reading from, who do you think is really pushing the boundary right now? Who should we really be paying attention to, and what they're putting out, or what group do you think is doing it?
Well, I'm not really familiar with many of them, but David Wiltshire is he's very well regarded, and he has done work concerning time and voids, and how time is different when it passes through voids. Time speeds up through voids. So it's related to what, I mean, I relate that to semi-quiet zones and how time is different in semi-quiet zones. And that might indicate distances measured are all agreeing with each other. If they test a measurement using 3 different methods, they're all agreeing that something is a particular distance away, but none of them are taking into account that there may be a void between where we are observing and where that light is coming from. So yeah, David Wiltshire is one that I would recommend, I guess, to researchers if they want to find out more about that. Now, he does agree about the Big Bang and early universe, or at least that's what his papers assume. And I think they make that as an assumption. It's not proven. So that's one thing that you taught me is about proof. And I'll just say this before I get sort of had a little bit of anxiety before going on to make a presentation or something. And I had to do this in Chicago one time, and she checked in. Just checked into the room I was in just to say, how you doing? And I said, can you do my report for me? You know, but she said one thing you should remember: just leave yourself out of it. And at that time, it was hard to do that, but I never forgot it. Thank you.
Okay. Well, there's an old story that Sandra Bernhardt, the famous actress from century before the last one now, she supposedly would get really nervous and throw up before she went on stage, even when she was very well known. And a young actress came up to her and said, "Oh, why do you get so nervous?" "I don't get nervous." And she said, "Well, when you're good, you will." So that's not a bad thing to be a little nervous. I was going to ask, you go back to this assumption about homogeneity, right? That everything's the same. Was that do we think that is part of the thinking because it was sort of a choice in the sense of, well, we know in the old days they made the stupid mistake of thinking the Earth was the center, and then they thought the sun was the center, and we're going to be more advanced. We know we're not special, so part of our postulate is that we're not in any special place. Or, and maybe it's both of these things, is it just a necessity? Because if you're going to come up with, kind of a logical necessity, because if you're going to come up with rules that explain the whole universe, you can't sort of postulate that it's just changing, somewhere else, and you're trying to come up with universal rules. So if all of a sudden there's no consistency in these things, you're self-limiting your explanation, which is kind of puts you in a kind of a box of your own making. I don't know. It's more of a philosophical question of how that came to be the case, or just accepted, or because it's driving all these corrections that need to be made. Whereas if you say, well, what if there's a big blob in the middle that, as opposed to, everything's the same. I don't know, just throw that out there.
They just say everything's a mystery when they don't understand it. And that
right.
seems to satisfy people,
Well, yeah, as long as you don't put the word God in it, then they don't have no problem with it, right? We're going to make up dark energy, dark matter. But if you said that was, a bunch of matter that's described in a religious book, then you get an argument. So it's a different thing. Anyway, Tom.
As you pointed out, the James Webb Telescope has kind of given pause to the way that most cosmologists believe that galaxies form. They're forming way too quickly. But that's no problem for the big name cosmologists. They're going to look past that and say, no, there's still no problem. We just have to figure out a new model on how galaxies form. So don't give up on it. The Big Bang still is it's still the main deal. And those galaxies that are forming they just need a new model. We'll figure it out. We'll get it down. Don't worry. So there's a lot that's just the way evolution works, though. Things slow down, things speed up. And but that, as Marjorie said, there'll be a lot of new hypotheses that cannot be proven that will come out there to make a difference. So thanks again, David. That's a great job.
Thank you.
Thanks, Tom. Andrew?
Hey, David, very good. Loved it. I wanted to comment on a couple things and then ask a question. I saw maybe 6 or 8 months ago, just came across an article, one of my science feeds, where someone had postulated an actual rotating universe with a 500 million year cycle that they claim took away some of these mathematical anomalies that the two different approaches have. I haven't seen any follows up on that, but I thought it was interesting, and also that there had been earlier an idea of a rotating universe that was actually part of the mainstream thinking at one time, and then got blown out by the Big Bang theory. But that's one of the things I wanted to ask you. You mentioned the cosmic background, Now, when I came across that in Scientific American quite a while ago, and ever since, I don't really understand how that became to be described as the smoking gun for the Big Bang. Um, can you can you explain that? Why that is so convincing to so many people? Because it didn't never clicked for me.
Maybe it's because early on, when it was first discovered, they figured it was all the same. And then they actually launched a satellite to, I don't know if it was exclusively to measure the temperature ranges. And then they saw all of these differences, the cold spots and they call it the axis of evil. I don't know why. It's just a measurement. But it's sort of it's actually putting holes in the theory that um
But but
it's
but
relevant for that
what I'm
proving
not what I don't understand is how did that, when it was originally discovered, become described as the smoking gun for the Big Bang? Like reading the articles, I just couldn't see that. Oh, this cosmic background is here. That means there was a Big Bang. I mean, smoking gun is sort of, your most solid evidence you can have in that kind of speech.
yeah.
So
I think
can you see how that scientific thinking can say, oh, this background here says something, some speck of nothingness at some point in time, nowhere, banged, leading to what we have now.
well I think it's really indicative of the difference between measurements and theories. The Big Bang is just a theory, and so is the explanations for the cosmic microwave background. So if something is a smoking gun, it's just the smoking gun is like a theoretical gun that's smoking theoretical smoke, I guess.
Well, I would say like Einstein's relativity, when they measured the light um, during an eclipse, they actually saw it bent from gravity.
Yeah,
From my thinking, that would have been a smoking gun showing that his theory was correct. I can never make that kind of connection with Big Bang and this cosmic
right,
background that was discovered. I couldn't see how those connect, and I've tried, but
right.
and I've not had anybody actually explain to me this is why we think this proves that there was a Big Bang.
Well,
And
yeah,
again, using the word prove.
some theories are correct, and it's just hard to
Okay.
make them reasonable. Some theories are correct, and some theories are just theories trying to explain some data. And what we have as a Urantia book students is revealed data. And we have to, if you're going to use the Urantia book as a scientific element, you have to understand that these are like our axioms. We can't prove that there's a paradise at the center. Um, but we're told that there is. And if you put all that data together, and I think with AI, to put all of the data of the Urantia book, all these specs and pieces that are even in places you never even think they would be, and associate them, pattern match these things. I think it's a very reasonable. The Urantia book is a very reasonable disclosure document about what's going on. I think so.
From my perspective, I don't know a lot of the things in the Urantia book are true, but the things I do know are true are all in the Urantia book about my relationship to God and, my relationship to you guys and everybody
Yeah.
else. But I use that as a scaffolding. And for me, the what's described in the Urantia book works. The universe can actually be like the Urantia book says from my observations. And I do watch science evolve, and it seems to be evolving close more and more in that direction.
Before we close, I want to give Ralph. Do you have any comments or words of wisdom for those of you? You know, Ralph is the father, so to speak, of a lot of these scientific efforts. David's efforts, our Science Symposium. Do you have any comments or closing thoughts?
Yeah, first off, I'd like to thank David for a fascinating presentation, for introducing us to the use of of AI to study the Urantia book. I think there's a real future there for utilizing AI to assist us in putting together some of the very complicated concepts and ideas and so on that thus far probably none of us have really done with the use of our brain cells that we have. So I think AI is a real asset to us. One point I would like to mention that has to do with understanding science is that and understanding the book really, because the book is limited to largely to the finite level of the universe, which is where we dwell. We know that the so-called basic rules, the basic concepts that govern activity and events on the ultimate level are very different. Here, we as scientists have all grown up with the idea of the conservation of energy and matter. On the ultimate level, that does not seem to be the case. There we have transcendentalers functioning. We have beings that just appear apparently, and so on. So we're down here at a low level of the cosmic realities. It's a little bit like some of the foggy mornings we experience here. We live in a river valleys, and in the fall, in the morning, we get dense fog down here at the almost at the bottom of the valley where we happen to be located. Whereas as we climb out of the valley, we get above the fog. And in a certain sense, we're all relegated to living in a certain amount of fog at the present time because of the level of the universe that we are existing on, and that's this material level. One other quick point I'd like to make is that much of the universe is dark to us. We know that the ultimatons are completely dark to us, so to speak, and that it's only when they become active as chemically active, which we deal with chemistry here, of course, but the ultimatons are above and beyond that, and they may well represent and may well be the cause of many of the effects that are observed, thought to be due to dark matter. I think I would like to mention one quick other point, and that is that I think we would benefit by a serious study of what the book does teach us about the God, the ultimate level, because that is an area that the book indicates is within our grasp in our future ascension. So it does give us a lot of hints and I think insights into what we can look forward to at that level of the universe and of our ascension career.
Well, thank you, Ralph, for for those comments and for your work in science and for your great friendship over the years.
Oh, you're welcome, David. It's been a pleasure.